You're listening to Gradient Dissent, a show about making machine learning work in the real world. And I'm your host, Lukas Biewald. All right, today I'm talking with Thomas, the CEO of GitHub. I've obviously been looking forward to this interview for quite a while. GitHub is one of those products that I've used nearly every day of my professional career for over a decade, and I have a real attachment to it. I was really excited after Microsoft bought GitHub and their innovation accelerated. And it's interesting timing for me because if you haven't heard, Weights and Biases was recently acquired by CoreWeave, and GitHub was one of the analogies that I used in my head of a successful acquisition. So I talked to him and get advice from him actually on camera about how to make an acquisition successful. But we also get into how GitHub Copilot works, why it's worked so well, where it's weak today, and how they think about the future of coding. I hope you enjoyed this one.
All right, so Thomas, so thanks for joining us. I guess we were just talking before we started recording about acquisitions, and you've been on both sides. Do you have any advice for me and my team post acquisition of Weights and Biases?
I would say stay sane, get some sleep in between, the craziness that as that process. As you mentioned, I've been, both the seller of a startup. I was the co-founder of a company called Hockey App that we sold to Microsoft in late 2014. And so I know what that was like with my team going through that acquisition until the last moment. We were just chatting before the pod started that, and then everything was signed. We were sitting at dinner, and it was an emptiness surrounding us. Like you feel like you should be more happy than you are in that moment, and then it takes some time to actually process that everything is now changing in your life. I've been obviously involved in the GitHub deal in 2018, mostly behind the scenes. And then after we had acquired GitHub, we bought I think 6 or 7 small to medium-sized companies. And I remember a number of conversations with the founder CEOs of the company we were acquiring, and the emotions that went through them, and I could empathize with them and understand where they're coming from, kind of like relating back to my own experience. So it is something for founder, CEO, or founder team to sell their company. An experience in life that is probably hard to compare to anything else.
Well, I wonder if it was like this for you, but one thing about this transaction is, I couldn't talk about it with anyone for quite a long time. And it was also kind of very slow where, kind of it felt done, but then we're kind of working through lots of details. And then there's like lots of regulatory approvals. So, it feels honestly to me like very anticlimactic. And also I'm kind of like, okay, I actually have been wanting to like, just kind of like work on the future stuff,
Yep.
for a long time, but couldn't. So it felt very unmomentous, I guess, to me, but it probably felt like a much bigger deal to all the people around me who are kind of just learning about it and going through that
Well,
change.
and why you can't during that phase where you cannot tell people that this is happening, then you also have to, you're almost forced into lying to a certain degree, or planning for a future that will no longer happen, where you may commit to an offsite or a customer event, and then okay, but by the time that actually would materialize, there's like a
Nice.
a mosquito around me. By the time that actually materializes, the world will look fundamentally different. And then you tell people, and of course you deal with a lot of uncertainty and doubt. And I'm sure you have gotten the question, Lucas, what's going to be my role in the future company? What is going to be your role? And people, the tendency is that they doubt what you're saying is actually the truth, given that as soon as these deals are closed, and you moved into the new office, either virtually or in reality, you realize that the grass isn't always greener on the other side, and there's as many problems often in the buyer company than they were in the seller company. So yeah, I hope everything works smoothly for you and your team. And next time maybe we talk about the life after, and what it's now like after everything is fully closed and integrated and so on.
Yeah, no, I appreciate it. It's a very unfamiliar experience for me, honestly, because I've spent most of my career running companies, and I didn't think
Yeah.
I was like attached to the
CEO title particularly, but it's one big difference actually is like, I can't like really guarantee people that I can control, what happens. Like it's a very different kind of conversation. I feel a lot more empathy for the managers that have worked for me in the past now. I actually haven't had that experience where, like I think I feel like it's really making more sense to me why people want so much clarity from their leaders and fast decision making and things. I actually think it will make
Yeah.
me a better CEO to be on the other side of this, for a period of time.
Yeah, naturally you lost a little bit of control, right? Because one way or another, now you have a manager above you,
For sure,
or a
yeah.
set of managers and the board and whatnot. And while people might trust you, they haven't got to the point yet where they have seen you reacting to instruction, direction, command, if you will, from your management chain. And then that certainly is a different life. And I think in many ways, that is what is so fundamentally different between being a leader in a medium-sized to large company, including me as GitHub CEO, because obviously we're part of Microsoft, and I have a management chain within that construct and deal, with the Microsoft finance team and HR and all these kind of things. With us being a founder, CEO, where you live with a different uncertainty. What does tomorrow look like, or what does the company look like in a year? But there's, other than your board, if you have one, there isn't really anyone telling you what to do. And I always felt like, as a startup founder, that is the ultimate freedom that you can have, even more so if you have a bootstrap startup where there isn't really a board or venture capitalists or investors or anything like that. But it's not that you wake up every morning and everything is a happy place. And even more so when you have a product in market and now you have customers and they have support issues, and I'm sure you have seen that they emailed you and says, hey, your team hasn't gotten back to me and I'm really frustrated and I'm paying you so much money. And then you're like, oh, okay, I was planning to have a nice night with my family, and now I'm dealing with this customer escalation, right? So
Yeah, that is the job. I'm curious, actually, we're immediately going off script. I love it. But, I mean, I feel like GitHub actually, from the outside, feels like one of the most successful acquisitions that I can even think of. I mean, this is such a softball question, I guess. But what do you think made made the GitHub acquisition so successful? And was it a success? Was it all that you hoped? Having like kind of thought about it before it happened and now running it.
yeah, I mean, I would say if you ask around in Microsoft leadership, the answer would clearly be yes. This was one of our most successful acquisitions. I think the other two that are always listed in a similar realm are LinkedIn, which has very similar integration model where they have a certain level of independence. Ryan Roslansky is the CEO. They have their own offices, their own brand. If you go to LinkedIn.com, there isn't much Microsoft in terms of branding or anything like that, and it's very much perceived as an independent platform within the Microsoft ecosystem. The other one is Minecraft, which was a very different acquisition. Also, how it started and how it went through. But similarly, right, the brand is very independent. Most kids playing Minecraft, that's probably their first touch point with the Microsoft ecosystem, unless they're playing Minecraft on a PC. But if they have it on their iPhone or Android phone or on a tablet, but they're getting handed from their parents, it's not even that. And so you have these three brands, and GitHub kind of sits in the middle. It is more of an enterprise brand, right? That's where we make most of our revenue. But at the same time, it has this recognition from consumers. Like my favorite example is when I go to the Lego store in the Pacific Northwest. Naturally, a lot of the employees there are students, and so they know what GitHub is, and so they are as much a fan of the company that I'm running as I'm a Lego fan, and you don't get that with many other enterprise companies, and part of that is obviously that GitHub is both an open source company hosting all these open source projects, and a company that sells enterprise products to many of the companies that want to work like an open source project, want to emulate a lot of these practices, or they're sitting somewhere in the middle, that they are both providing open source like your company, and have a part of the stack that is closed source. So yeah, we're really happy about the acquisition. Revenue has grown. We announced in July of 2024 over 2 billion run rate. And you can look up yourself what the rumors were back in 2018. I don't think there's an officially published number, but it's significantly up. Acquisitions often have scorecards, so the scorecard on the revenue side is more than green. The scorecard on the growth side is more than green, and with Copilot, a post-acquisition and with the OpenAI investment in 2019, we kind of materialized the best of Microsoft with its cloud and experience and responsible AI and all these kind of pieces, the best of GitHub with our developer-first approach and the OpenAI partnership, which gave us access to first GPT-3 and then the Codex model to build, the original Copilot, GitHub Copilot.
Okay, but so why is it so green? Is it the OpenAI connection? Because I feel like even before that, like one thing that I noticed from the outside is that it seemed like the development actually accelerated post-acquisition. Like that was my impression as a user. I don't know if it felt like that on the inside, but yeah, like what happened there?
As part of the deal, we actually defined the three acquisition principles or integration principles. And the first one was, and I think that's really part of our success, is that above everything, we put the developer first. And in many ways, you could argue GitHub has always done that since it was founded. It was founded, by hackers that had discovered that Git is cool and
Thomas,
Chris,
did you know actually? Did I tell you? They
No?
God, they worked for me, so I'm actually like user number
Well.
7 of GitHub or something. I don't know if I ever mentioned that.
I don't think
Yeah.
you did.
Yeah, it's
Yeah.
funny. I was like there when they started. It was on my co-founder's couch actually that they were
Yeah.
hackers.
So yeah,
Anyway.
Chris, Tom, PJ, and then
Yeah.
Scott as kind of like the fourth late founder, right? Like it's really actually fun to go to the Wayback Machine and look at what GitHub.com looked like in the very early days.
Totally.
I think many folks have a much more evolved picture in their head of what the UI looked like and what the front page looked like. But the reality was that it was almost like a commit log with like single line updates from Chris, I think mostly saying, "Yep, we have this new feature, check it out." That was all that was there on the front page. And the UI, looked much more, basic than it is today. And I think many people kind of like have this 2015, 2016 evolution in their head as that was GitHub was always like. But obviously in the early days of this cloud native, Web 2 or whatever you want to call that wave of startups, look much more simple than today. And so we put developers first, right? And so whether we write blog posts, whether we build products, we have all internal processes. Everybody at GitHub across every roles, HR, finance, legal, product management, they're all using GitHub every single day. I think the only other tool that we're using as much as GitHub is Slack. That's the two tools as a remote first company that we're using very intensively, and but that helps us, to evolve the product. The second principle was, and that I think is the mistake in many acquisitions, we thought about how is Microsoft accelerating GitHub, right? But I think in many acquisitions it's the other way around. You think about how you find synergies between the company that you bought and the company that's buying you, and you're looking at how is the startup accelerating the big company. And we thought about how is Microsoft accelerating GitHub. And I think that's where you see things like GitHub Actions, which was, an effort where we took an existing technology out of Azure DevOps called Azure Pipelines and brought that into GitHub. And it looks like GitHub, and it has a different format of defining these workflows. But the underlying technology and part of the team came over in early 2019 to build what is today GitHub Actions. And so you can kind of like track that progress. In part of the success was that we very quickly figured out how can we do joint sales with the Microsoft sales team around the world, which gave us coverage that in GitHub, at the time of the acquisition was about 800 employees, could never have. And that helped us to accelerate. But really, Microsoft invested into GitHub to let it grow. And I think that is crucial. And in many ways, it's almost like a D round or E round or whatever, Series E of an investment. And then the last principle, the third one was how does GitHub accelerate Microsoft? And we always said that comes later. And we will think about that when we have figured out the other two pieces. And Copilot, I would say, was probably the first one where we were very intentional about taking our learnings, partnering with Azure, building on top of a joint stack between the GitHub Copilot and all the other copilots that Microsoft now has, leveraging the responsible AI pieces that Microsoft offered us, but also contributing back to that. And so that, I think, is what describes the success of GitHub now, almost 7 years after we announced the acquisition in 2018.
And so, I mean, Copilot is this really incredible product. I think it was for a lot of people, the first time really seeing, the power of LLMs. Like I remember, when I first, kind of started to use it, just like this, oh my God, feeling of like kind of seeing like how amazing, this could be. I guess, I wonder with that product, like I feel like there's so much momentum in Silicon Valley about like you hear like kind of like Codium and you hear about like kind of Cursor, and it doesn't feel like Copilot has the same, I don't know, like purchase inside the brains of at least like Silicon Valley companies. Like how do you think about that? Like do you feel like you're behind in some ways and you're planning to catch up, or is it like I guess what is like Cursor doing even that's like different than what like Copilot offers?
Yeah, I mean, I think we were very early when we started with Copilot in middle of 2020, when there was almost no AI hype whatsoever. GPT-3 was available to some nerds and data scientists and people that understood what large language model do, and oftentimes you had to explain what a transformer is first to a customer before we get to the point of why this might be changing the world. And June 2021 is when we launched the preview of Copilot. And, you may say we created that whole market with that one announcement. And was a very short blog post and a site that really, a landing page that showed how code completion worked for different languages and different examples. And if you travel back in time on Hacker News and other pages, there was equal amount of skepticism than excitement, and we started giving people access to the private preview, and some were skeptical and then turned around, and you kind of saw that evolution happening of saying, oh, after using it for a while, I actually see the significant impact. And there were legal challenges and discussions around fair use on the training side and replicating a code and licenses. And so a lot of the investment in the early days was just scaling out a Copilot. I think we had 1 million users on the waitlist within less than a year, and then in the private preview, so waitlist, and then going through the waitlist into the private preview. And so we had to also just scale the architecture in that first year, and that was the public launch. What we call GA, general availability, was June 2022. So even that was before ChatGPT, right? Like that, this whole time horizon is so compressed with so many things that have happened since then. That it's easy to forget that a Copilot was not only in preview; it was a GA product before ChatGPT came out. And I was actually on a trip right after the ChatGPT launch, and I could see it in every customer conversation I had, whether it was in Tokyo, Singapore, and Sydney, that the world had dramatically changed. It went from AI as kind of this cool technology, but we're far away from that future and it actually being useful, to Thomas, tell me more how you build Copilot, how we can adopt Copilot. We had the first case studies where we showed that developers are 55% faster. But ultimately, the play for GitHub is that we have the platform. And so when you buy GitHub Copilot, you not only get it in VS Code and in JetBrains and in Xcode and Android Studio and whatnot, you're also getting it in GitHub, and you're getting a code review agent to look at your pull requests. And so just in earnings, Microsoft earnings last week, we published that Copilot has now 15 million users, and the Copilot code review agent, just as an example of that platform play, has reviewed over 8 million pull requests. And I think that's where we're seeing the future, as this holistic workflow where you have Copilot for auto completion, you have chat, you have agent mode, you have MCP integration, And then it continues, in your pull request to review code, to fix security vulnerabilities. And with Project Padawan, which we announced earlier this year as, one of the early, or how do you say this, as one of the projects we're working on to implement a software engineering agent or SWE agent. You will even have a flow where you can go from issue to pull request just with the help of an agent.
Mm. And do you have like a sense? I mean, I think you've thrown out different numbers. A lot of people kind of talk about, productivity gains. I myself wonder how you even possibly really measure that. But do you have any sense on what the speed up is, or like I guess what are you even like kind of shooting for with these projects?
We're ultimately shooting for making every software engineering team, starting with ourselves, able to deal with the ever-growing number of lines of code and the complexity that comes with that. The problem with, when you compare productivity gains between, without Copilot and with Copilot, the challenge you have is that you're never working on the same thing twice. You can do case studies, and that's where the 55% came from, where we gave 50 developers a task to do it without Copilot and 50 with Copilot, and the team with Copilot, and everybody did the same thing, right? And the team with Copilot was 55% faster. But that obviously is a clinical study, if you will. It isn't reflective of the real world. I would never have 100 developers in my team do exactly the same thing. And even the one that works on the same topic, right, on the same subsystem or micro system or whatever, they're not doing the same thing day on, day on. In fact, they're adding more stuff to the existing service. And so the complexity is always rising. And so when you look at productivity gains, you got to ask what's the baseline of what you're comparing against. And ultimately, the AI making AI part of the developer workflow had two impacts. One is that we actually increased the complexity for the developers building this system, because full stacks now means backend and database and all that infrastructure, front end, and now you also have AI, which means you have to integrate models and eval them and fine-tune or post-train them and operate them, and then you have things like what OpenAI recently saw, that they have a new version of the model and they tuned it too far in the one direction, and they have to roll that back. But even if you don't want to wait for customer feedback on that, you have to have really good eval test suites and a really solid monitoring process, which is not fundamentally different to monitoring your uptime and your exceptions in Sentry and all these kind of things, but it adds another complexity layer to our development teams. So what AI has done to almost all software engineering companies, because the expectation is now that you're integrating AI into your stack, is that you increase the complexity. And on the other side, it has made coding much easier. I think autocompletion is all about flow and staying in flow state. When you're typing a code in VS Code yourself, and it predicts the next 10 lines of code, it removes you from the obligation to go into your browser and search for how you use a key vault or how you do this algorithm, or even simple things when you work in a Ruby on Rails app and you have a model with a couple of columns, and go into the controller and you want to instantiate the model. Just having it tell you what are the different attributes of that model, and some of that already obviously work with IntelliSense or IntelliCode, just more classic autocompletion, but it really keeps you in that flow state. And oftentimes developers just can accept code, and then it's close enough to what you're trying to achieve to then go and modify the pieces that are broken, have syntax errors and whatnot. And let's face it, that was also true when we copied stock code of Stack Overflow or of GitHub repos or from blog posts, right? That code was never actually perfect. You had to take it, you had to paste it into your code, and then you had to make it work. And so that's where I think autocompletion has really improved the flow state. And now with next edit suggestions, you can just tap from one suggestion to another. The latest VS Code has actually now the auto completions also with a syntax highlighting, so you can even pass that a bit more than the original Ghost tag. And this brings us back to the early days. This UI concept of Ghost tags of basically showing you 10 lines of code within the editor that you can autocomplete into. That didn't exist. Like, we built that in partnership with the VS Code team for the original Copilot. Before that, autocompletion was a drop-down where you could, scroll through the different option from the documentation, or in TextMate, I think it captured what else it had in that file and created kind of like a DSL out of that. Not a DSL, but like a menu of options. And so now if you go into agent mode and SWE agents and or things like bold.new or lovable, Vercells v0, right? In many ways, if you know how to prompt it, you can actually have it write all the code, right? Like v0 as an example, like you give it a prompt and it renders you the whole web page, and behind the scenes, it obviously uses Next.js, and then you click a single button and it deploys it to a Vercel, and so it was never easier to spin up a quick web page for your wedding or for your birthday invitation, or even to sell like a pop-up store, like sell a product real quick. And then you can use prompts to redefine that code. But I think where we are, and so that's super efficient, right? Because you often don't even need to hire a developer anymore. And you see a bunch of examples out there where the users of these tools are not actually folks with a software engineering background. They just heard about this on your podcast or elsewhere, that this is cool, and then they're trying it out. And similar to how they've used ChatGPT to render an image, and when the image isn't exactly what you want, you redefine it with more prompts. They're doing that with these web pages. Where I think the biggest challenge lies is that the majority of actual, big scale software projects, like VS Code is one, GitHub is one, weights and biases and others, is that the complexity of these projects is so high that today the agents cannot actually tackle those. Much in the same way that, there isn't still so far we haven't, gotten a car into the market that you can buy that has no steering wheel. The closest is, Waymo in San Francisco, and a bunch of other cities, but it's ring-fenced to that problem space and has a bunch of extra sensors. I think that comparison applies to agents as well. There are certain scenarios where that works well, but there's a whole big complexity out there where it doesn't work well, and where the agent or agent mode in VS Code it takes a file and adds the 2 lines you wanted, and it removes 5,000 lines or screws them up in some form. And I think that's where it's becoming crucial that developers, A, still need to know how to code, and B, can make a very educated decision whether they want to use the agent or just go into the file themselves and make that one-line change where they know exactly how to do it, where to do it. Like, it's almost like a waste of energy and time if you're trying to write a prompt for something that you can write much faster in code yourself. And so having this continuum from having AI infused into the editor with code completion to asking coding questions, explain the code, inline chat, and those kind of things, all the way to agent mode and autonomous agent, I think those two things all belong together. And as developers, we want to move, in both directions, up and down that spectrum. And if you see a pull request that was created by a SWE agent and you see a bug in there, what you want to do is go into the comment line, say, use the GitHub CLI to check out that pull request, and then just keep working in VS Code or any of your other favorite IDEs.
Do you think that's going to be true 3 or 4 years from now? Like, when yeah, like how do you know that, right? Because it seems pretty clear. Like, you could look at the situation and be like, well, it's like getting better and better. Like, every month it seems to be, better. Why aren't there? Why won't it get better at kind of going into like, specific parts of the code and changing it? Which I totally acknowledge you definitely have to do today, especially on like a larger code base. But so many smart people are working on it. Why doesn't that get fixed?
It's getting better. Certainly the models are getting better, but in some ways you could argue now in 2025, we're still fighting some of the same problems we were fighting back in 2020 with GPT-3 and Codex, where the model just writes code that is a little broken, or, mistypes an import statement in Python. And now with agent mode, it can use tools, and it, can fix itself by looking at the error message. But I think fundamentally the role of a software engineer is not just to create new code and new files, but actually to design an application that is, unique, for the mission, the OKRs, whatever that's driving you. And part of that is that you want to build a successful business that grows revenue and returns profit to the owners or the shareholders. And I think that systems thinking, how to design the application, how to decide between MySQL and Postgres, or between React and jQuery, or I don't know. That maybe is an easy decision. Go and use React.
A little bit of
you know what I'm saying,
dated,
right? Like there's 10,000 choices to make when you're building an application with decent complexity. Just like when you're building a house, and almost no house looks exactly the same as another house, and almost no application looks exactly the same. And if that were true, if it can just create code with a few prompts, that startup has no value, because then everybody else could also build that, right? And so the complexity will just significantly grow as these agents become more powerful. I think the flip side of that is that, well, we're here in 2025, and many, if not all, of the financial services institutions, banks, and insurances have still some kind of mainframe COBOL, legacy code, unless the bank was founded in the last 10 years and didn't do any acquisition. But that journey of managing old code that somebody else has written, and figuring out what the developer was intending, how can I refactor this? Are there actual unit tests? And if there are unit tests, do they cover enough of that? That is actually the bigger part of software engineering, right? Like if I switch sides and join your company as an engineer today, my biggest challenge is to understand how this all works. And while I could use an agent to achieve my goal here, how do I validate that what the agent has written is actually correct and doesn't introduce a new security vulnerability, or doesn't make the thing so much slower that you need 10 times the compute to now run that platform? I think that back and forth between the agent and its output and the developer is going to stay crucial for many years to come, let alone that obviously there's also a lot of security risks of accepting code into the code base without understanding what the code actually does, right? This IT calls it zero trust principle. Today, most companies don't allow any developer to push into the main branch. They force a pull request review with a different reviewer, branch protection, all those kind of things. Run CI/CD, and only if all these things are green, then you can merge it back and deploy it, right? That we're doing that because we're worried about attacks. We're worried about the model. We're going to be worried about the model writing code that injects a security vulnerability, whether that came from an attacker or whether it came from a built-in vulnerability into the model, is effectively irrelevant. We have to deal with that risk, and that risk is mitigated by human reviewing that code. And maybe they're using AI for that as well, and I can see that happening. But I think ultimately we gotta have humans understanding code. You gotta have humans designing systems and making decisions of when to use an agent, burn through GPU cycles to write code that actually generates value for the companies we work for.
I guess then you've written about sort of like this long arc of kind of like leveling up to higher levels of abstraction in the world of software development. I mean, I totally agree, right? Like, I think, I sort of felt bad when I was in college for not like going deeper on like C, because that sort of felt like an essential software skill, but maybe unless you're in certain domains, like less and less important over time. But I guess you're also talking here about like sort of going in and being able to like there's sort of an architectural level of kind of almost like a manager, like software architect mindset of like like what database should I use here and how should I kind of like lay out my application. But you're also talking about sort of like going in and actually kind of modifying some of the code, or at least like understanding it for security reasons or reliability reasons. But it also seems like why wouldn't the software be better than a human at kind of like writing tests and doing like security reviews? Like why doesn't that get automated away?
It will get automated, I think, to a high degree. If you look at having AI writing documentation or unit test cases, it already works to a significant degree Although we also got to be real, the most popular benchmark right now is SWE-bench, SWE-bench, which has 2,000 pairs of issues and pull requests from a dozen Python repos. And the best agent in SWE-bench is like at 62, 63%. I think.
Well, we were at the top of it until recently.
For a while,
I will
but
tell you.
But 65% of dozen Python repos is like returning with 65% from a math school in high school, from a math test in high school. That's not a great result, right? 90% I would say we're getting there. But even that is like a 10% gap of uncertainty in a business. And this week, the founders of SWE-bench built out the multilingual version, and they also announced an agent that can generate new test data for those agents. And with this multilingual, I think the numbers go significantly down into the 20s to 30 ranges. So we're far away from this agent to actually be at 100%. Will that point happen? Of course, in the same way that we are going to see fully self-driving cars. But we don't know when we get to that point, because it's not an easy problem to solve, and it's not one that hasn't been solved before. But I wanted to come back to, the fundamental part of your question, which is the machine that we're ultimately building software for still runs on a processor that has, a built-in instruction set that is abstracted all the way to the programming language, but not higher than that. The programming language is the last deterministic abstraction layer that basically maps directly into the instructions that the CPU or GPU executes. Natural language is inherently non-deterministic, because you can both say the same sentence or describe the same user interface and then build a completely different website with different design and a different functionality, different databases and so on. And so having that I think is going to be the craft of a software engineer, is being able to jump between those two abstraction layers and making decisions of when can I just describe it in natural language, because that's ultimately how we're thinking in our brains. And how we're thinking, when we wake up in the morning and we have an idea about something you want to build, we're thinking that in English or German or whatever language you have in your head. And then the challenge in the past was, how do I convert that now into programming language? And that's often more frustrating than most folks want to admit, because it takes way longer than you thought it might take. And then it's easy enough, to pull in an open source library until you realize, okay, so this actually created a whole new problem in my application. Maybe now you have a dependency that requires you to upgrade to a newer version of Rails or what have you. And so I think, that conversion of being able to take my idea, describe it in a few bullets, or even use Claude 3.7 Sonnet is super powerful in kind of this reason with a model what my specification looks like, and then you create, a markdown file in your project, and then you're feeding that into Copilot agent mode to have it then, actually implement that. I think that's the new way of working, but it still requires an engineer, right? Like to kind of do that thought process, figure out the user interface flow, building an amazing product, and then jumping down into the coding layer to find, the one line that's broken and that you need to fix to compile the application.
Do you find with suddenly all these people using automated systems that your kind of user metrics are changing a lot, like in the last year? Like I would think that automated code generation would potentially make like a massive increase in the amount of code getting sent to GitHub. I would think that like you might get kind of more branching because like models are like more comfortable like just generating tons of pull requests. Are you seeing effects like that in your own data?
I mean, I think the biggest one we are seeing is that adoption has significantly increased. And
Adoption of
the
coding.
AI.
Yeah.
AI is now part of the life cycle, and it's no more a question whether software developers should use AI as part of their day-to-day workflow. Whether that's in the inner loop, when writing on my computer and code completion, chat, agent mode, everything that's kind of like synchronous with me and my machine, or whether it's, in the outer loop and pull request reviews, summarizing the pull request, having, the SWE agent build the pull request itself. And so I think it's accepted, best practice now to use AI in your workflow. That doesn't mean everybody has adopted it, but I think we are way past the chasm, and we are now talking about the late majority, if not, the laggards that are even later. And that's where you see, this in very intense competition in the developer tool space. I would, argue I've never seen anything like that in my 30 years, since I started coding on a Commodore 64, in terms of, you mentioned a few startups earlier, but it's not only the startups, it's also, all the hyperscalers that have AI coding tools. IBM has one, and everybody is playing in that space, and the extended version of that, from training models to fine-tuning models to having an AI stack all the way to coding tools. If you will, the biggest use case for AI today is software development, and maybe that gets us to the point where then AI, becomes AGI, when the AI can write its own code and improve its own code. And so adoption is one thing. I think it's accepted now that AI is part of the developer workflow. How much code it's writing is constantly increasing. The models are getting better. We have been now shipping a new code completion model every month, and we have an ongoing mid and post training process to improve, the code completion model with online testing, offline and online testing, and seeing in those experiments how much the accepted and retained characters. That's one of the key metrics that we're looking at. Is like, when you get a completion, how many of those characters do you accept? And then how do you retain them? And so there's a window where we're looking in the editor what you're doing and if you're modifying those characters. So that's a metric we're tracking. And based on that metric from offline and online testing, we then decide, is that model flight good enough to become the May model, which is the code completion model that Copilot is using. And I think that's where, even though code completion, you could argue, is somewhat commoditized now and everybody considered as a standard feature, there's still a lot of improvement happening based on metrics and making the models more efficient, improving the margins, or just the number of GPUs you need for it, and ultimately improving the user experience and having them get more accurate code with lower latency. And latency, by the way, is, I think, latency in many ways is the core metric for every developer tool. Like, if it isn't fast, you're always going to have an audience of software developers that are going to be not happy. And even with these agents, and I think that's going to be a big problem, both for the synchronous agent on your machine and the asynchronous agent that runs in the cloud, is like, I don't want to watch an agent do its work for 15 minutes. What I do is I start it. If it doesn't have any question, it goes running, and then I go and do something else. But we all know context switching is hard. So how many of those agents can you really start and then go to another branch on your computer before this becomes more annoying and destroying your flow than actually helping you? So even that, how do you keep the developer in the flow state, and how do you keep the agents fast enough that it feels fun? I think that's going to be described. That's going to just be describing a lot of the innovation that's going to happen in the next year, and that's why you hear many of the folks in the industry saying that with agents, what the software development looks like will fundamentally change over the next 6, 12, maybe 24 months.
Yeah, it's funny. I guess from where I sit, it kind of feels like it's already changed. This is my own personal workflow, I guess, but I find myself using a lot more like agentic code generation than tabs these days, which I think it's a lot less fun. Actually, like I kind of like that you're talking about the like fun of coding, because the context switching is like horrible, right? It goes from like coding taking me into a flow state to coding, meaning I have to like fight my brain to stay focused while I like, frustrating like wait for the thing to finish. But I think it's more efficient for me. Like, obviously you have to support both uses. Like, do you look at how much people are doing in those two different ways of engaging. And am I the unusual one here that I've kind of moved to more of the longer pauses? Are most people just tab completing?
I mean, yes. I mean, most people are still mostly tab completing. I think if that's just the nature of things, right? Like you're not changing how the majority of developers work overnight, and there's certainly within the developer and AI code gen space a whole different S curve of early adopters of agent mode. I think that's still a smaller population than the large majority that has adopted code completion. And let's face it, code completion, that was one of the magic of the original Copilot. You didn't have to adopt anything. And we could have probably announced this and not even mention AI and just say, here's cooler code completion. And it's there. And if you don't like it, just ignore the ghost text or, Command Shift Peak. Disable Copilot is always fair game if you're annoyed by it as well. Especially when you're working in a file where you might not even want, the content of that file go to model inference. And so we see an adoption spectrum between, code completion, which has the highest adoption, chat and inline chat, all the way to agent mode. And agent mode, I think to some degree is still something that developers have to learn. And where there's scenarios where it makes sense to now start vibe coding with the agent versus just, doing it yourself. And Toby Lutke, the Shopify CEO, recently had this memo for the whole company saying AI is now baseline expectation as Shopify. And I think the most fun bullet in that memo was if you want more headcount, you first have to show that you can do it with AI and increase the productivity of the company. And I think that shows you where the thought process is. But the thing, with agent mode is that if it takes too long as a developer, you're always going to have the question in your head is, could I have done that faster myself? And so I think that's a culture change and a mindset change that will keep going. And as the models get faster and more efficient and kind of user behavior shows at what point you want to take over and say, okay, this is good enough, I can do it. We are going to see a behavioral change across the population. I actually think a lot of my weekend coding is fun in the sense that, look, my hobby projects I don't run any unit tests and I don't submit a pull request against myself either, right? Because what I really want is I have this idea, I want to write some code, I want to see it light up as an app in my dock or as a web page, and then I want to feel good about this, right? And I was like, look what amazing thing I just created with just a bunch of lines of code and a computer. And that was always the magic for me in software development, right? Like you didn't have to build a factory first and tools and all that. You could get any computer, the earliest PCs or the Apple II, and they had a programming language that was the operating system was BASIC, even on the Altair, even though that didn't even have a keyboard and a monitor. And so that I think that dream is still there for many developers. I have an idea and I want to implement something. So now if you can do that and then spin off an agent in the backend to write to the unit tests, and you don't even have to watch that because you can just write the next method, and in the meantime it has built you the 15 unit tests for that one method, and then it runs it and fixes it itself, and that happens in the background, and you have to watch that. So you can just focus on the next method in your class. That I think is keeping you in the flow state because you're not going from the thing that is fun, which is really building features and functionality, to the thing that is usually not fun for software developers, which is writing unit tests and then running them, and you wait, and then the last one fails, and now you're okay. What did I do wrong here, and why is this one not meeting the assertion? And I think that's where we're going to see a lot of user interface innovation over the coming month. Spinning off these agents and keeping the developer in the flow state and letting them really do what they want to do.
Is that like a core guiding principle for you to like make it fun? Because I would think like a lot of CEOs would be like, don't really care if my developers are having fun. I want them to, be productive here.
Certainly, it's like developer happiness is certainly one of our principles, and we definitely believe that if developers are not happy, they're not productive, and if they're not productive, they're not building amazing products. I think those are very strongly correlated to each other, and it goes both ways, right? Like if your tool chain is bad, that means your NSAT or your NPS is going down, and your developers get grumpy about the tool chain and they have to wait forever. And we know that even at the scale of Microsoft. Before I became the GitHub CEO, for some time I ran Microsoft engineering system team called 1ES, and one of their biggest projects was bring down the build time for the Office suite from days down to, I think, 8 hours is where we ultimately ended. And
Wow,
even
it's
that
8 hours to build the
but
Office suite?
yeah. I mean, 8 hours sounds like a lot, but if you're coming down from like 3 days, you realize at 8 hours is actually good, because it means you can, start a build and then take off for the night, and then the next morning you have a fresh build, right? Whereas
Wow.
if it took days, and so
Wait, so
paralyzing.
what happens if somebody breaks the build in some cross-functional way? Is it just like down for like a month while people like figure out what went wrong, or how did...
Well, I don't know what the answer to that is because I was in the team. But I mean obviously at the scale of an Office suite or Windows, you have many builds running every night, and so
Sure.
one broken build is not slowing everybody down. It's just slowing
Right.
down that team on that branch or that a feature workflow, and then they had to probably spend the day out. But yeah, I mean, if that's the latency problem at a really large scale, right? Like if your turnaround time is 8 hours, and and we have that actually, in model training now, right? Like model training runs for these really large frontier models takes so long that if you make a mistake or there's a power outage and that interrupts the training run, you have wasted a lot of ultimately money in form of energy and resources that is now wasted time. So keeping these supercomputers or clusters up and running to do the model training in itself is, I think, a crucial part of training frontier models. But yeah, so coming back to this Office example, right? So the goal there was just bring down the build time, which means to have to parallelize the builds over multiple machines, which then raises the question: okay, so how do we do that with dependencies, and where do the object files go, and what artifact storage do you have that's fast enough so the uploading the file into an artifact store and then downloading it on another machine for that next object file compilation isn't actually slowing down the build process. Right? And I think it's these kind of like optimization problems that we are going to see in a new form in AI, in this AI native workflow. I think the funny thing is actually AI native is a misnomer, right? Like, because it's AI first or AI infused, but nobody is actually AI native yet. We all learn coding without AI, right? So we might be cloud native. We grew up with the cloud, although I didn't. I think you didn't either. But certainly it became a whole, and then you can become a cloud native startup. The first really AI native startups, I think, are yet to come, where it's like truly AI native. What we, when we in 10 years look back, say, yeah, this is when and things fundamentally changed, and now companies were just built in a whole different way.
A conversation that I have all the time, I have a feeling, you might have this too, is like talking to executives that want to like push their team to use more of these, like, kind of use more code automation. It always seems really baffling to me. Like I sort of feel like, if it's obviously more productive, like wouldn't, people adopt it? Like I'm not going to tell my engineers, what tools to use, but I'm going to be frustrated if they're like not as productive as they could be. I mean, do you come across this? Like I just scratch my head with like, if an engineer wouldn't adopt a tool that would make them like 50% more productive, it just seems really they're like ridiculous to me. But I'm curious what your experiences of this. Do you like push like using tools internally to try to get your team to be more AI native?
So we adopted or adapted the Shopify memo in some form within some modified form within GitHub, and made that similar, or I made similar statements to GitHub that the usage of Copilot and AI tools is part of our culture and mandatory where it makes sense. Obviously, we don't want a salesperson use Copilot in the same intensity as an engineer does, but there's many other AI tools, that they should be using as part of their workflow. So that's where I think we're past that point where that is actually a question. In the same way that, at GitHub, it is part of every employee to use Git and GitHub. That's not optional. You cannot say, okay, I store my source code, on Azure Blob Storage or Dropbox or anything like that. Which, it's like you're laughing, but like we also know from telemetry that still is very prevalent in software development, especially in hobby projects, student projects, or companies are just doing something else in software development is somewhat in a corner case of what they do day in, day out. While Git adoption certainly has grown significantly over the lifetime of GitHub, there's also still a market to capture for us just on the platform and moving companies into Git. So nobody questions whether employees at GitHub should be using Git. I think we're at the point where that is also true for Copilot and AI tools in general. But that doesn't mean, that needs to be 100% of the day. And I think you still need to think about when it makes sense and doesn't make sense. That decision making, do you do control space on your Mac to open ChatGPT into input panel, ask a question, or do you Google it? And I think that feels somewhat more natural now. But it is not binary. There's a gray area. We could do both, and then often it's driven by your belief system. And I think the question you ask is, why do developers not use AI, even though the metrics are clear? I think part of that is belief system, and kind of like, this is how I have always worked. And now that I have these auto completions or the agent mode, I'm forced into a way of working that I don't actually like. And now I have to read more code and understand it than write code, and I have to write prompts, but I don't want to really write prompts. And it's this culture change and ultimately the change of how we do things as humanity that we know takes time. And it's just not done by forcing people into this new way of working. And in fact, I think what we're going to see is a bit of a shift in the performance curve of the employee population. Like, when you do performance rankings or evaluations and those kind of things, the employees that were good maybe 5 years ago in that way of working may not be at the top of their whole or class in that new way. And because adopting to that world, it's I'm a big F1 fan, and in Formula One, this way it always works is there's new regulations, and then the first 2 years or so, one team had it figured out early, and so they're ahead of everybody else, Red Bull, in the current regulations. And then they're getting closer and closer to each other, and then you have really, really tight races, and you have a fantastic season like 2021. And then they're changing the regulations. And now there's new regulations, and there's a new way of driving these cars, and all of a sudden, a different team and a different driver can handle this new, a type of car, current era's crown effect. What the Vettel area, Sebastian Vettel area, was where the diffuser was connected to the exhaust and whatnot, right? So there's different drivers handling those conditions better, and then they win the championship. And I think same is true for developers in this new world of AI. You got to be able to adapt, learn, and be willing to kind of like evolve your mindset into what is now the state of the art of software development.
Totally. I totally agree with that. Do you also feel like the skills that someone would need to be a good developer are changing? Like I sort of feel like maybe more product oriented mindset would probably help in a world where the actual like implementation gets easier.
The technical details have gone away, right? Like in the 90s, you had to know about the CPU and the cache and the memory and the bus, if you even had a hard drive or cassette tape, and then so you had to really be in the intricacies of the hardware architecture you're building for, and that led to things like the 386 having a turbo switch. The turbo switch wasn't to make things faster; it was to slow down the software that was so optimized for the architecture that it would run way too fast, and so you couldn't play the games anymore. Right? So you slowed things down because everything was so optimized. And so those developers that know exactly how the PC works and the instruction set of the CPU and maybe write an assembler function to run that certain part faster, they are like a minority of the whole developer ecosystem. Similar for developers that can write shaders in computer games. That there's certainly demand for that, but the majority of full stack developers don't know that skill. And so I think we have always moved up the stack and left something behind intentionally because the complexity has grown so much. And so the skill that I think the future developer needs, if not the current developer already, is systems thinking. Like taking, this problem that you're getting from your product manager or your boss, your engineering manager, and breaking it down into a small enough chunk that now you have enough of a way of taking that abstract problem and converting it into code, right? That ultimately is what software developers do today. You take a description of a feature and then you're kind of like in your head or on with a pen and paper, you're breaking it down into small pieces of work that you can, do during your workday. And I think that thinking doesn't go away, but it moves at an even higher layer. And today, if you go into Copilot, ChatGPT, Bold, whatever, and you tell it to build you GitHub, well, it gives you probably a page that looks like GitHub. Maybe you should try that after the podcast. But it certainly doesn't give you, all the features, and it certainly doesn't give you the scale of hosting, more than 500 million repos. Let alone it doesn't give you the Git stack or we call it Git systems and all the pieces that are part of that application. And that goes back to are we in 5 years at the point where that works with just AI? I doubt it. Because like designing, a system like GitHub or weights and biases or CoreWeave or whatever, that is still requires engineering skills, architecture, or that's why I like it to summarize it as systems thinking. The other side is this notion of a full stack builder, where you actually no longer have a PM and a designer and an engineer, and testers are already gone for most companies anyway, and SRE has merged with software development as part of DevOps roles. But basically having a single person that can take an idea and work with one model or agent to mock out the spec and the designs, and then create the Figmas, and probably using some form of design system. The one that we have at GitHub is called Primer, because then the AI can compose these components into a page, and then taking it into the business logic and application logic with an agent, writing all the test cases, writing your actions deploy script, deploying it to the cloud, and have an SRE agent monitor this all, scale it up and down, look at exceptions, maybe take those exceptions, file a GitHub issue, and then you take, the SWE agent to implement that fix. I think that full stack builder is, if it not already exists in some small startups or very innovative companies, is going to soon, become a role in a company. And
well, if you're out there, I want to work with you. I'll say that. That sounds like an amazing.
And what you're going to have is like the Venn diagram between what a PM is doing, what an engineer is doing, what a designer is doing. Even a marketer is going to have a much higher overlap. So you can, a really good PM that can write a really good GitHub issue of what a feature should look like and hit exactly the right abstraction level to then assign it to Copilot, and then Copilot, spins up GitHub Actions and uses tools and MCP and all these kind of pieces to implement that feature, creates a pull request, and then you review that pull request, and that's where the engineer might come in and say, yep, what the PM created here, but you might have the PM basically building the whole code change, the diff in the form of a pull request with the help of an agent, and so the engineer becomes much more of a a conductor of an orchestra of agent, together with the co-workers in the company. But I do think, and I'm not the only one predicting that, but I do think we are going to see very small companies that have very high valuations. And in fact, with WhatsApp and Instagram and others, we have already seen examples of that before AI. But we're certainly going to see that, and I think that's super exciting. You can kind of build a business in your garage all over again at a much bigger scale.
Yeah, because like not everything is. I mean, I think first of all, like making something as advanced as GitHub is kind of like on the outer edge of like what you need to do engineering wise to make something useful, and these systems are getting better, right? Like I don't know about you, I think we're about the same age. Like I remember, like programming, like really like basic computers, and like just being excited I can make like I don't know, like a circle grow in size or something. And it's like funny to watch my daughter at like age 5, like we like vibe code together in the same, they're the same. It's like the same mindset, I think.
Yeah.
Like when I was like a little kid doing it with my dad, but like, I mean, she can make a real web app, like, and it's like, and like, kids have such weird, crazy, like creative ideas. Like I sort of feel like when these, like, when teenagers and even younger can start like, deploying their own, like really realizing their own ideas, like into things, I just feel like we're going to get like a real Cambrian explosion of applications.
Yeah, I mean, absolutely. By the way, I'm born 78.
Yeah, similar. Yeah.
I learned coding first in East Germany on in the geography lab in the late 80s with a
Wow.
Robotron computer. It was a clone of a Z80 chip, I think, was in there, and a cassette tape and all that. It was,
Oh.
in my head, I think, it merges with my early experience on a Commodore 64, which I bought, I think, 1991. That's where I really learned coding, because I had that at home connected to TV. When you say drawing a circle, in my head, I'm like, well, drawing a circle, even that, the Commodore 64 didn't come with a graphical user interface, right? It was all text-based, and then you had to switch into pixel mode. And like, I don't think there was a predefined method to draw a circle, and you couldn't just download an open source library either. And so I bought magazines and books, and then the listings in the magazines. I will not forget that the listings were not actually listings; they were checksums. And so you had to mail stamps to the publisher to get a disc back with the program, the app. Nobody called it app back then. The program that decoded those checksums back into the code, because you could print the checksums almost like a QR code in of the 1990s. You could print them much more dense than you would print code, right? So you would type those checksums into the Commodore 64, then to decode the checksums into the code, and then you had a library that you could use to draw a circle or do a side scroller and those kind of things. And my kids are 12, almost 13, and 10. And so same thing, I actually bought them Copilot before we had the free tier that we have now. I bought them Copilot because they always would come to my desk, show me their MacBook with their Python, mostly Pygame stuff, and say, here, I have a problem here. Go and fix my bug. And I'm like, well, I'm talking to Lukas right now. Can we do that later? And obviously for them, the answer is no. This is way more higher priority. And then you give them something like Copilot, and now they can highlight that code and ask questions or use agent mode. And I think kids are so much faster in adopting that new way of thinking because it aligns so closely to how they discover the world and learn, right? Like by asking questions. And when you have the first time actually my kids used AI was, I think it was on their own, was Adobe Firefly. And they had seen that somewhere in school, and they came home and say, hey, look, we have these puppy images. And I'm like, where did you get these puppy? Oh, we signed up for an Adobe account. And I'm like, what? And I was like, yeah, you type prompt and you get a puppy image, and you type another prompt and you get a better puppy image. And so they very quickly learned this. Okay, so if I don't like what the answer I got, well, I asked another question, because that's exactly how they interact with their families and their parents, their teachers anyway, right? Like they keep asking questions. They don't like the answer that you're giving them. They're asking you another questions. And I think but you have to combine that with getting coding and computer science into every school. And I've been, in fact, on Monday this week, May 5th, in partnership with code.org, more than 250 CEOs signed an open letter to bring computer education into more schools. Because again, like, okay, so you have an agent that does powerful things, but if you don't understand what it actually created, if you cannot read the code, if you cannot validate, if you cannot, fix bugs, you're actually giving up, something that makes us human. And in the same way that we're teaching all the kids physics and chemistry, and obviously art and sciences and literacy and math. And that doesn't mean you just become a physicist just because you had physics in school, right? Like there's still, you're picking your career path based on your interests and economic value and those kind of things. But I think it's fundamental for everyone on this planet to understand code and computer science, as these devices will only have devices and the agents will only have a higher play a more stronger and higher importance role in our lives than they already play.
Well, that seems like a nice place to end, Thomas. I appreciate your time. This is a lot of fun. Thank you.
Thank you so much for having me, and I agree, it was super fun and great conversation.
Thanks so much for listening to this episode of Gradient Dissent. Please stay tuned for future episodes.